Hello, welcome back to our second lesson in the rational units. Today's going to be a fun one. Again, there's absolutely nothing new here today. All we're doing is adding and subtracting rational expressions, which means we're going to have to incorporate factoring and a common denominator, and then just adding, subtracting fractions. So if you're coming in with strong fraction skills from grade 7 and 8, and you're coming in with strong factoring skills from grade 10, this is easy. And I did give you the heads up that if you're struggling with it, well, you have lots of time now to practice up on those skills. Okay, so nothing new, which is the good part. But unfortunately, these questions are long and tedious. So they're not hard, nothing new, but long and tedious. So just go slowly and carefully. The first times you don't have to redo it, and just don't give up, just it's long and tedious. And just to let you know, this is probably, I guess, the worst lesson in this unit, and just that you can see they get pretty long and tedious. But stick with it and just be confident that all that mental math that we did at the start of the year to brush up on your fraction work and factoring work has paid off, and it won't be that bad today. Okay, so there's not really any notes to do because adding and subtracting rational expressions is exactly the same rules as adding and subtracting fractions back in grade 7 and 8. The only difference is you're gonna have to do some factoring and have some polynomial work involved. But otherwise, exact same things you've been doing since grade 10. Okay, so we're just gonna look at 4 different categories. So the first one is when they already have a common denominator. Well, that's really nice. So you're not going to get a lot of these, but we'll start with them just to review how you would add and subtract rational expressions that already have a common denominator. So it's easy, you don't have to adjust anything. So we look, yeah, all 3 have the common denominator. So now you just add and subtract the numerators as you would with any other fraction. So 2 plus 5 is 7, minus 3 is 4. Now again, you don't add the y's. It's the same thing as doing your fraction work. You just add the numerators, you leave the denominator as it is. So your answer should be 4 over y. That's it. That's as easy as it gets. But we did learn last lesson about how to do non-permissibles. So after you've added or subtracted, then you just state your non-permissible y cannot equal 0. So if you understand that lesson, that example, that's pretty easy. But unfortunately, the rest of our examples don't have a common denominator. So we're gonna have some pre-steps to get a common denominator, but once we get to this step, you just add, subtract the numerators, state non-permissibles. That easy. Okay, so the second, we have another example, still with a common denominator. Now we have an x plus 3, x plus 3. The denominators are the same, that's good, so we can just go straight ahead to the question. So the numerator, 2x minus 4. What's 2x minus 4? Well, 2x minus 4 is just 2x minus 4. We can't simplify it. Again, the denominator stays the same, just like you've been doing your fraction work since grade 7 and 8. And then our new step is stating a non-permissible x cannot equal negative 3. So if they already have a common denominator, they're quite nice. But unfortunately, this is grade 11 pre-cal, so when you go into grade 12 in calculus, most often they will not have a common denominator. So the rest of the examples, we'll look at questions where your starting example does not have the same denominator. So what are the steps there? Well, step 1, we have to find the LCD, lowest common denominator. But like I said, that's not a new concept. You've been working with LCDs for many years now. So you should be good at figuring out what the LCD is. Once you figure out the lowest common denominator, then you adjust your numerators. I find that's the step that gives most students the problem. We can get the LCD, the adjusting, not that it's hard, but a lot of students actually forget to do this step. So if you skip that step, that's a major concept error. So find your LCD, don't forget to adjust the numerators, and then after you adjust the numerators, the rest is easy. Then you just add and subtract as it is and state your non-permissibles. That goes back to our first example. So if they don't have a common denominator, find the LCD, adjust the numerators, then the rest is like our first 2 examples we did. Okay, easier said than done for some of them. Let's give it a try. So we have a blank screen. The next example is denominators that have a common binomial factor. I find all the examples we're going to do today, this is the one that students struggle with the most. So our example, 2 over 2m minus 4 plus 5 over 3m minus 6. Very clearly, they do not have the same denominator, so we can't just do 2 plus 5, 7, and we're done. Not that easy. So step number 1 is factoring. So the factoring is quite easy factoring. This is a common factor back from grade 10 math. So in math, there is a reason why we do everything. It's not just to make your life miserable and give you lots of homework. Everything we learn has a purpose and we reuse it. So that's the fun part about math. The reason why you were taught fractions in grade 7 and 8 and factoring in grade 10 is so you can use it in grade 11. I find that really exciting. So that's where the fun part is of math. That's also the hard part, because anything that you had troubles with in the past and maybe didn't work on it will now show up again in grade 11. So there is a reason though why we teach you everything. We just don't teach it and forget about it. It does come back somewhere in the future. So that's why we learned about common factoring in grade 10, so we can use it in this lesson now. Okay, so now we factored. Well, that didn't really help. I still don't have a common denominator. So now I have to figure out the LCD. This is tough. We've done LCD since, well, many years, but it's a little different applying it to rational expressions. So we know that they have an m minus 2 in common. So we know we keep that. That's part of it. Now 2 and 3. What's the LCD between 2 and 3? They have nothing in common, so you'd go with 6. So it's the same work you've done in previous years. I know in grade 10 math, we did a lot of work with GCF and we call it LCM, lowest common multiple, which would be the lowest common denominator. So again, we did talk about it last year, but now we're just involving some polynomials. So your LCD is 6m minus 2. That's going to be the toughest part of these examples. Just figure out what your LCD is. Okay, now we are ready for step 3. We're ready to adjust the numerators. So I just went back to where we were when we factored. We just said that's the LCD. So now we have to adjust the numerator. Again, a lot of students forget that step. If you forget to adjust the numerator, you're kind of missing the whole point of this question. So they both have the m minus 2, so that's good. We don't have to worry about that. But 6, we have a 2 here. How do we make the 2 a 6? You'd have to multiply the numerator and the denominator by 3. What you do to the top, you do to the bottom. Remember when we did our conjugates and rationalizing binomial denominators? What did you multiply the top by? You have to multiply the denominator by. Okay, this side has the m minus 2, that's good, but 3 is not the same as 6. So to make the 3 a 6, you multiply the numerator and denominator by 2. Looks easy, but that's harder to do. You'll see when you're trying your example. That's kind of the tricky part. The rest, though, it's long and tedious, but the hardest part is done. The hardest part is getting that LCD and adjusting the numerator. So now as we go through, this is just very simple math for us. The rest should be easy. 3 times 2 is 6. 2 times 5 is 10. And oh look, we're back to where we were example 1.